Hello class! Today we're going to be talking about sections 9.4, measures of variation, and section 10.4, box and whisker plots. Now, before you get started, hopefully you're getting used to the routine and you know that you should have your math notebook out and something to write with as well. Remember that your notes are going to be a great resource for you when we're working on practice in class, when you're working on independent practice, and of course for your assessments. So please make sure you're following along and taking detailed notes. All right, so let's get started. Our essential question for today is, how can you use quartiles to represent data graphically? And we're going to talk about that concept here shortly, but first let's begin with one of our main topics for today, which is, what is a measure of variation? And a measure of variation is a measure that describes the distribution of a data set. That describes the distribution of a data set. So how is data distributed? And one of the main components of that is going to be something called range. And what range is the difference between the greatest and the least value in your set. So the difference between the greatest and least values in the data set. Now, before we move on to an example, I first want to give you some other common words that are used to describe the greatest and least values. You'll commonly see the greatest called the max or the maximum, and you'll also commonly see the least be called the min or the minimum. And this will be important for you when we're talking about box and whisker plots for our 5-number summary, because that's what they are most commonly called there. All right, so now that we have some background info on range, let's go ahead and try to find the range of a data set. So right here in this example given, it shows us the number of pets and it gives us some data values. So let's first start off by finding the biggest or greatest value, and then let's find the least value in the set, and then find the difference of them. So of course, remember, you can always put these data values in order if that's easier for you, or if you can just pinpoint them from looking at the data set, you can also do that. So in this case, I can see that 17 is clearly the largest value. And then right next to it, 0, I can clearly see that that's the biggest value or the smallest value as well. So our range equals our max minus our min, and we'll just plug in those values. So the range is equal to 17 minus 0, which is pretty easy math and just equals 17. So that's one example of finding the range. Now that we have an idea of range, let's go ahead and move on to one of our next big topics, which is something called a quartile. So the quartiles of a data set divide our data into 4 equal parts. So the quartiles of a data set divide data into 4 equal parts. And for those 4 equal parts, we are going to talk about 3 quartiles. You might be thinking, okay, well, if it divides it into 4 equal parts, why do we only have 3 quartiles? And I'm going to show you right over here to the side. So when you're looking at this diagram over here to the left, you see that there's 3 divisions, but that's going to show 1 part right here, 1 right here, 1 right here, and 1 right here. So just understand that those 3 divided into 4 equal parts, but there's only 3 of them, since that's all it takes to divide it into 4 parts. All right, so one of the key concepts that we already learned about when we talked about our last section was median, and median is going to be a super important concept for us to find quartiles. So luckily, you're already one step ahead of the game. So quartile 1 is the median of the lower half of a data set. So that's the median of the lower half, that's the big idea here, of the data set. Our next quartile 2 we've already actually talked about and already know how to find, and that's the median of a data set. So our median is also known as quartile 2. And then our very last one, you might guess, quartile 3, is the median of the upper half of the data set. So that one's the median of the upper half of the data set. And you might be thinking, okay, well, how do I know where the upper half and the lower half are? Don't worry, we're going to talk about that in just a second, and we're also going to do examples so you can start to understand how you are going to do this in your own practice. All right, so here's one example from the book that's given right here. And this shows a data set that is divided into different quartiles. So first you see the data set was split right in half, and that's where we see the median. And remember, in order to find that median, since this was the even number, they took the average of 28 and 30. So they added those and then divided by 2 to get 29. So once they split that data in half, then they would have to find the median of this part of the data, the lower half, and the median of this part of the data, the upper half. And since there were 5 values in each of those sets, they would just identify the center value, since that's an odd number in that set. And in this case, for the lower half, it was 22, and the upper half, it was 32. All right? So we're going to talk about and do our own example here in just a second. But before we do, we're going to talk about one more component, which is called interquartile range. An interquartile range, similar to range, is going to be the difference between quartile 3, which is our highest quartile, and quartile 1. So this is the difference between quartile 3 and quartile 1, which are our highest and our lowest quartiles. So you'll see that as IQR equals Q3 minus Q1. And that's exactly how you will solve this. All right, so let's move on to the foundation of our 5-number summary, and then we're going to start to work on examples for all of this so we can become more familiar with it. So what is a 5-number summary? A 5-number summary is the 5 numbers, and remember you can abbreviate in your notes as long as you understand what the symbols mean, that make up a box and whisker plot. And these 5 values include our min, our max, our Q1, Q2, and Q3. So these are the 5 numbers in a 5-number summary. So now that we have all of our big key concepts and definitions, let's actually put these to action and do an example here. So we're going to basically put together everything we've just learned into one mega example, and we're going to show that for you right here. All right, so let's go ahead and do this. So it says find the 5-number summary and the IQR of the following data set. Remember that Q1, Q2, and Q3 are involved in the 5-number summary, so we're going to see practice from that above example right here. So this data set that we have right here, luckily, is already in order for us, so that saves us a step. But remember, anytime you're finding the median, by now, hopefully you have it in your brain that the data set needs to be in order. It already is here, so we don't have an extra step to do. So now the first thing you're going to want to do is you're always going to want to find the quartile 2 or the median first. So find Q2 first. And the reason for that is because we need to divide this data set in half, so we first need to find what the median is and then split it up. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. That's an even amount, so that means we're going to have 2 values in the middle. So 1, 2, 3, 4, 5, 6. I'm going to split that right in half, and then 1, 2, 3, 4, 5, 6 on that side. Just make sure you split them up evenly. And in this case, remember, anytime we have the same number in the center, our median is just going to be that number because, of course, In between 30 and 30 is just going to be 30. But like I said, I always want to prove it to you because that's what we're supposed to do with our work. So I'm going to show you my work for Q2. So we're going to take 30 plus 30 and divide it by 2. Remember, anytime we have an even number in our set, that means we're going to have two numbers in the middle, and we have to find the mean or average of those. And remember, a little review, when you're finding the mean, you're going to add the values, so take the sum of them, and then divide by how many values there are. In this case, we're only talking about 2, so we add 30 plus 30, then divide by 2. 60 divided by 2 just gives us 30. Like I said, that's kind of an obvious one since obviously 30 is in between 30 and 30, but I still wanted to show you the work that goes along with it so you don't get confused. All right, so now we split our data set in half, and we have these 6 values on this side and the 6 values on this side. So what we're going to do is we're going to find the median of each. So remember, the median of this half, our lower half, is going to be called quartile 1, and our median of the upper half, of course, is going to be called quartile 3. So since there's 6 values on each side, we're going to have 2 values in the middle, and we're going to have to use that same strategy. So this is going to be for Q1. We are going to do 20 plus 26 since we have to find the mean of those, and then we're going to divide by 2. That gives us 46 divided by 2, which of course is 23. And then Q3 will be our last one. We're going to find our 2 centers there, 33 and 35, and of course we're going to find the median of those. So we're going to add those values, remember, get the mean of them, divide by 2 since there's 2 values in that set, and we're going to end up with 68 divided by 2, which is going to give us 34. Remember, it's always a great idea to check for the reasonability of your answers, so make sure they make sense because that will help you catch an easy mistake in case you made one. For example, a common mistake is to divide by how many values are in the set rather than how many values you're talking about for a median, which is 2. So for example, if I divided 46 by how many values were in the set, which is 12, I would get something very small like 3, and that wouldn't make sense that that was in between 20 and 26. So please check to try to catch simple mistakes if you make any. In this case, all of these values make sense. All right, so now that we have Q1, Q2, and Q3, we need to find our minimum and our maximum as well. So let's go ahead and do that. We can find the value to the most left, which is our minimum. So our minimum is 14, super simple. And we find our value to the most right only when they're in order. That's our maximum, and that is 38. So now we have all the values we need to do the last component of our notes, which is a box and whisker plot. And before I draw a box and whisker plot for you, let me kind of describe what it is for you. So a box and whisker plot is a visual representation of data. And remember, I abbreviate sometimes in the notes just to make it easier, but make sure you know what the words actually mean that you're abbreviating. So a visual representation of data along a number line that uses the 5-number summary. Oops, I'm sorry, I made a little mistake right there. Along a number line that uses the 5-number summary to display the variability of data. That uses the 5-number summary to display the variability of data. So how data varies. And we're going to show you exactly how to do that here in just a second. And that is going to be our last component of the notes. All right, so the first thing I'm going to do is, since I'm scrolling down, I'm going to write all these values here to the side so we have them to reference once I scroll for the rest. So I'm going to write our minimum value, which equals 14. I'm going to write our Q1, which equals 23, our Q2, which equals 34, our Q3 equal to, oops, I mixed those up. Wait, Q2 was supposed to equal 30, and Q3 was supposed to equal 34, and our max value was 38. All right, so when we scroll down here, we are now going to create our box and whisker plot. So as it says here in the definition, we always start with a number line. So something you should remember from creating dot plots is that your number line always has to have an even scale. That means you can't go like 1, 5, 7, 9, 12, 13, 14. It has to either go by ones, by twos, by threes, by fives, whatever you choose. It has to be the same across the board. So in this case, our data ranges from 14 to 38. So we want to pick a scale that allows us to display all of the values in between 14 and 38. So I think I'm going to start and go by tens. So I'm going to start with 10 over here, and I'm going to go by tens to try to fit all of my data on the plot. So I'm going to go 10, 15, I'm sorry, I said tens. I'm going to go by fives, 20, 25, 30, 35, 40. And when we have a scale that doesn't have the direct numbers, we're just going to estimate about where they would go. All right, so you were probably wondering this whole time, well, why is this called a box and whisker plot? That's kind of a ridiculous name. It's because basically we use box and whiskers, and you're going to see what I'm talking about here in just a second. So above the number line, we're going to put a dot at each of the values. So we're going to start with 14. 14 would be about right beside 15, so I'm going to put 14 about right here. Then Q1 would be at 23. That would be about in between 20 and 25. So I'm going to put that right there. Q2 would be at 30. Luckily, we have 30 right there on the line, so it would be right above it. Then we have 34, which would be right beside 35. And then our last value, 38, which is right before 40. All right, so we start off with all of those dots. And now we have to make our box and whisker plot. So something you need to know is anytime our minimum and our maximum connect to our quartiles, those are the whiskers. So we're just going to draw a line for those. And then our quartiles are going to be like boxes. So I always say, remember this, because quartile is like a tile. It's like a box. And so we are going to have to draw a box for our quartiles. Looks just like that. And voila, we have our box and we have our whiskers, and this is exactly how to draw a box and whisker plot. So I'm going to write this so you remember. So quartiles, you have to draw a box for them, and for the min and the max, you would draw the whiskers. All right, so at this point, we have covered everything in the notes. We've done a 5-number summary. We've shown that as a box and whisker plot. We've talked about the measures of variation, and we are all done. Make sure you have reference to these notes so you can use them for practice, and you will be all set for class. Thank you.